How about finding out the induced current's direction in a solenoid, not a straight conductor, but a solenoid? Then we make use of Lenz's law, which states that when the magnetic field around a solenoid changes, this induces current in the solenoid such that it sets up a magnetic field which would tend to oppose the change. If a magnet is thrust towards a solenoid such that its south pole is leading, the solenoid will react by inducing a current such that it would set up a magnetic field which would oppose this approaching south pole. How would it do that? Well, it would set up a magnetic field such that a south pole would be developed in it opposite the approaching south pole to tend to repel the approaching south pole. Remembering the right-hand solenoid rule, the current direction that would be needed to set up a south pole where shown would have to be in the direction shown in the diagram. Convince yourself of this. In the top diagram, what would the direction of the induced current be? In the bottom diagram, which direction would the magnet have to be moved to cause the current direction shown to be induced? Pause until you have answered this yourself. For the top diagram, current is induced such that its resulting magnetic field tends to pull back the retreating north pole. So what must the induced current direction be to set up a south pole at the left-hand side of the shown solenoid? For the bottom diagram, the right-hand solenoid rule shows that current has been induced in such a way that the top of the magnet is a north pole. Curl your fingers in this direction and the thumb will point to the top. In which direction must the approaching magnet be thrust in order to induce a north pole at the top of the solenoid? Here are the answers.